All right, so this talk bounces up a couple of levels from most of what you've heard today. Up until now, we've been talking mostly about managing resources that generative AI is deployed upon. So this talk is about applying agentic AI to a specific use case, and the use case we're going to be addressing here is looking at infrastructure as code using OpenTofu and Terraform as an example. So I'm hopeful that this talk provides insights on a couple of levels. One, that agentic applications, and I'm sorry, I've lost my mouse here, agentic applications and independent agents are going to be just another workload that you're going to need to consider, but also that you can use an agentic approach yourself to aid with any toil that you're experiencing in your own GitOps workflows. So I'm hopeful that you can walk away from this talk with a little bit of inspiration there. So I'm Jodee. I am your host today. I am a product manager for Outshift at Cisco. And I'll tell you that the Outshift team we're incubation arm, or one of the incubation arms at Cisco. And right now we're all focused on quantum computing and AI. So doubling down on that, which we manage on a lot of what you see, this cloud stack over here. So I'm based in Portland, Oregon, on the west coast of the United States, near the Cascade Mountain Range. We've got access to beaches and beautiful glaciated peaks. So I'm going to cover, first I'm going to start a little bit with something that I'm also going to end on. So we've just introduced a new open source collective. We've got a couple of major companies who are buying in on this so far. I'm going to talk about that really briefly. And then I want to talk about the core use case that that my talk is about. So looking at applying GenAI to infrastructure as code problems that are causing users toil today. I hope I have enough time for a couple of short demos. And then we'll talk about what's next, both for the work that my team has been doing at Outshift, but also for the new open source collective. So, since this talk is about an agentic approach, I really want to highlight this new open source collective that has just launched. Its mission is to support the Internet of Agents, is what we call it, where we really believe that there's going to be a vast quantity of AI agents that are going to need a way to interoperate. So the collective has actually already been building out specs and starting to build some of the software that we think is going to be necessary for this Internet of Agents. So QR code there, but you'll see it again later on. So back to our use case. We want to insert ourselves in a standard GitOps workflow at the review point. So we're reviewing OpenTofu or Terraform. I'm going to use them a little bit interchangeably. We're reviewing OpenTofu pull requests. So we picked this use case as one of primary interest for a number of reasons. We know that teams are having trouble with this. We have survey data already. It's not just the review. It is all about managing your day 2 onwards OpenTofu repository. So we know that users are facing a lot of pain in this space. There's a natural checkpoint here in a pull request review. So humans are always in the loop. They get to decide what code is merged. We're not going to merge code on their behalf, but we're going to provide recommendations to them. So we're going to be able to learn and build trust by observing what it is that the users actually do. So we're going to give recommendations to them, but we'll be able to see what actually happened at the end. So what code actually got merged, what recommendations were taken. And then we're also going to be able to, we're hopeful that at some point we might even start being able to write code. We did try out a number of existing offers out there, so both on the sort of code generation or helping users to write code, pilot kind of actions, as well as existing pull request review tools that were much more generic so they didn't perform that well for this particular use case. So again, Terraform, OpenTofu, pull request. All right, so starting here. So I'm a product manager. I go out and talk to users. Did a lot of research in this space, figured out what are the problems that users are having. So these are the top issues that came back to us. And ideally, our offer, whatever we do, should be able to help users with this. So I'm just going to talk about a couple of them because my time is very short here, but just to give you a sense of the problem. So often, usually, there's a really large code base of your OpenTofu code. Lots of layers of abstraction and dependencies, because this is what allows reuse. So the core benefit of infrastructure as code is let's make sure that we have consistency and reuse. Modules are one of the key building blocks of this reuse. And you'll often notice that business logic starts creeping into these modules and makes them less usable for future teams who want to deploy the same kind of resource. And modules are kind of tied to resources that you're going to deploy. So they end up building their own module. And we get this module creep where we get, a number of modules starts to become, out of control, and we have duplicate kind of logic in there. And then there's often, there's many policies and rules that need to be implemented, that need to be managed, and that we need to make sure that they're applied with consistency throughout. So I'm just going to touch on those ones, but notice also documentation comes in here, having very large plans and such. Those are things that we can really probably really effectively use GenAI to help with. So now we know our problem set, or at least we have a sense of it. How did we go about addressing it? So a little bit of context. So what are agents and what is Agentic? A few other folks have mentioned these things earlier on today, so make sure that we're set here, that the industry generally recognizes agents as acting autonomously, but that autonomous space that they act in is based on what we tell them to do. So they're just software. We program them, and we give them some inputs, and we ask for a set of outputs. So they act within the boundaries that we define for them. We also have Agentic, and generally Agentic is thought of as like the set of, we have a set of agents, and they're often created using an Agentic orchestration layer. And that orchestration layer, just think of that as between your model and the applications that you're actually deploying. And there's a number of Agentic orchestration frameworks out there that you can just take off the shelf. So LangGraph, Crew, Autogen, Bee, but think of these as kind of silos. I've even talked to customers who are building their own sort of frameworks because they've decided that they wanted a set of controls that weren't available in one of the other orchestration frameworks. But these help you make it easier to build your agents. So just a little bit further on agents. So an agentic application really breaks down a problem into a set of task-specific agents, or at least that's how we're thinking of it. Generally, we're thinking of a multi-agent sort of application where we have a number of agents that have very specific tasks. And you create a task effectively with a prompt. So an example agent prompt might be, you are an expert Terraform code reviewer. You are responsible for the following set of tasks as part of reviewing Terraform code. So then that prompt is then used with the selected model and returns an answer to your agentic application, which then you do something else with, or maybe you're done and you send that back to the user. So some of the benefits of an agentic approach are that you get to pick the best foundation model for your task. You get to augment each agent with just the information that's pertinent to the task that it's doing. So we can kind of avoid some of the hallucination that was mentioned, for instance, in the previous talk. So now we're done, right? That's all we need to do. Just build it. We've just built some agents, and we should be able to have a system. We ran into this problem, at least, and maybe you faced it yourself, is that for complex use cases, how do you decide what agents you need? So if we're assigning a task to an agent, how specific do tasks need to be? If we're not getting back the answers we need, do we just add another agent? Do we continue to refine the prompt? Like, how do we tweak our system so that we improve the quality of our answers? And then what sorts of resources does it take to do this? So if we now have 6 task-focused agents, does that take 6 times the resources when compared to, say, a single monolith? These are questions. So maybe we take our problem set on the right here, on your left, sorry, and does that become effectively the set of tasks or the set of agents that we create? So this is our question. So if we break that down a little bit, we find at least that we've got a whole bunch of code review tasks that need to be done. And then we have a number of other tasks that are also important or valuable to the user and have been causing toil. So maybe those other tasks, they all look kind of siloed. These are nicely segmented into something that I think individually an agent could perform on its own. So that seems logical. But we have this big code review problem where there's a whole bunch of tasks that need to be done or a whole bunch of things that need to be done as part of code review, but it all needs to be coordinated and consolidated as part of our work. So this is our problem. So this list on our right is the prompt. Is this also, do we need an agent for every single one of, for instance, these code review tasks? All right. Suffice it to say that our experimentation around code review has been showing so far that like a single shot, like a monolithic prompt where we are trying to cover off all of the code review items all in one go has led us to some fairly massive prompts. And we haven't been getting consistent results. We do get reasonably good insights into our code, but not always catching some of the harder problems that users have been struggling with. And our experimentation with existing pull request offers and such, and code assistance offers seems to lead us towards that we're getting sort of common, similar sorts of results from those sorts of systems. Now, there has already been plenty of data out there where PhD students and others have written papers about how breaking down a problem or even splitting up, assigning a problem to multiple agents or multiple systems and bringing back an answer and then consolidating it, that we get better answers in that way. So we hypothesize that by breaking down the problem into tuned task-specific agents, we can make our prompts small and hopefully make our agents smaller as well. And then taking all of our agent responses and consolidating them, and then if there's any conflicts, redirecting those back and doing some loops, reflecting them back as needed. That ideally, this sort of approach, we hypothesize, should make a very robust offer. So we started building some stuff. And we really have been on a journey here. So I'm going to I'm not going to talk to anything on all of these bullet points, but we're currently here at V2. So we switched agent orchestration layers really early on. We've gone back and forth between sequential and hierarchical approaches, and we got to a point where we have 7 agents. We're using a hierarchical approach, and that hierarchy is basically a supervisor that routes tasks to the right agents, and I'll show you kind of what this looks like. So it's a little easier to see what's going on in this view. We start at the top where we're taking in our pull request. We're actually also fetching some other related files, not as many as we should. We're starting to find that. We have this supervisor that then distributes the work to a PR title and description reviewer. So we've chosen to pick up one of those sort of documentation tasks as an early sort of test. We've got a very small code review team. And then we take that code, all the responses from the code review team, and we actually have a separate code consolidator agent that then, like, we bring feedback from the PR title and description and the consolidated code comments back to actually write to the pull request. So we've got some fetching tools where we're interacting with GitHub to pull in the pull request and actually also to write as well. But I'll note here, like, we know we have a lot of learnings already that we're missing more context. We really could be fetching a lot more of the information for this pull request from the related files and such from the repository. We'd really like to insert some user instructions. We know we need to break down the code reviewer more, but we've started just splitting out a couple of tasks just to see, do those make a difference? So we've added in a cross-reference check, pulled that out from the code reviewer, this big monolithic code reviewer, to see whether or not we catch more cross-reference errors. So just starting to break that out. All right, I want to, totally on the side here, before I get into a demo, I just want to mention this one point. In parallel, we have our SRE team built some things. So they built a whole bunch of agents roughly in the same time that we did. But they constrained their workflows to a set of 10 very tight self-service workflows for users that things like deploying a sandbox environment or giving out keys or creating keys for some of our developers to be able to access an approved LLM. So I bring up their work for a couple of reasons. So one, they also ended up with a hierarchical approach, so that helps us inform our decision. They've seen really good results generating code for Kubernetes deployments using a 5-agent system that incorporates multiple reflection steps. So they've got this 5 agents here that I have in the list. They're in the yellow. But the multiple reflection steps are sometimes happening 6, 7, 8 times to get to the quality of code that they feel confident in. So that's interesting. And also, they built a lot of agents, and they ended up being fairly task-specific for all of them. And they have a number of agents that will be really useful to our system as well when we start expanding our use cases beyond just pull request review. Like, we would really love to be able to pick up a Jira ticket and open a pull request, write some code and open a pull request that addresses that Jira ticket. So we'd rather not build that ourselves again if they've already got it. All right, I'm just going to show something really briefly. Let's see if I've got what. All right, just to give you a sense of what I'm talking about here. So we started building our system. We've chosen to test out our system in our production, on a copy of our production environment. And I'm saying a copy because we want to be able to run our service each time that we update it. It'd be really nice if we could test drive it in this production environment without writing a bunch of crap to the SRE team's Terraform repo. So we've got a kind of this reflection of their entire repository with all of their pull requests in it, so 700 plus, that we're able to actually go through and attempt our assessment on each of them. So in this case, there's been a Jira ticket open that we need to create a cloud front-end environment for one of our teams, and that is in this Jira ticket here. It's teeny tiny, and the only reason I'm showing this Jira ticket here is because there's almost no content in this Jira ticket. So again, there's almost no content here in the pull request that was actually open. So we ask our system to review it, and we're just code-naming it Alfred for now. And we get a really good response about like what it is that this system does. Let's see if we can get it better, a little bit bigger. So suggest a new title, that's probably less important, but the system has figured out exactly what it is that we're trying to accomplish here, and documented that for any of the reviewers or for anybody who wants to read it in the future. All right, that's moderately interesting. I think we can say that our model and our agent there does a really good job with this, and we could probably even tune this a little bit further so that we weren't using quite such a large model to do this piece of work, because it looks like it's fairly easy for it. We weigh on every commit. So if I scroll down through here, it's really, really long. So let's just look at one of these commits. So we're going to look at this one. And I've loaded these all up in advance because I'm worried about the Wi-Fi here. So we start commenting on, we're able to go through the code and comment on a number of potential issues here. All right, so this is interesting. And what I found quite interesting here is that we comment on one of the things that we've caught, that there's duplicate AWS resources, which actually in the title, in the description, we were able to identify that there is multiple AWS resources actually deliberately being created. So we could have possibly taken some of that input and fed it in, taken some of the input from the PR title and description reviewer and sent it off to the code reviewer. Anyhow, so that's just to give you a sense of what it's doing, and that's just one pull request. So we have 700 plus pull requests in the backlog. How do we go ahead and assess whether or not our offer has done a good job on all 700 plus pull requests? Hard to say. So just to give you a sense of what it is that, what's going on here in the background. So really briefly, we've just opened up somebody's just opened up a pull request. We go ahead and we are triggered. This system is triggered anytime a new pull request is open or anytime a comment is left. And then at that point, the system goes ahead and calls out we're using LangGraph as our orchestration layer, calls out each of the LangGraph nodes in turn. And you'll notice the title and description reviewer came in through here. So that happened here. And now we're sending the content off we're going ahead and using a deterministic tool here, because we may as well, because it's available to us, a static analyzer, and we've got some comments back already from that. And we send those off to the code reviewer. And then the code reviewer comes back already that it's actually responding back with some feedback already. Okay. And then just to have a look at that, you can see that, so that was just our logs. We can actually see what's happening in lane graph much more visually. So just looking at the latest run here, you can see that we're calling a number of different nodes or agents, and then look at a trace view and see like the static analyzer, here's the static analyzer trace, and it's come back with some information. And then it's sending it, you can see the code reviewer, and the code reviewer here, you can see that it's receiving input from the static analyzer. So just so you see what's going on behind the scenes a little bit. All right, and I'll stop it there. And then, okay, so that's just giving you a sense of what the pull request reviewer is actually doing. And then just to give you a sense of what the SRE team built as well, because this also might be of use to you. So they support a number of very defined workflows, as I mentioned. So for instance, I want access to an LLM. So I can enter one of our interfaces, user interfaces. This is me just asking this question, how do I get access? And it comes back with a very defined form that we're able to, but this is all done with AI agents in behind. So it decided, what is it that the user's trying to ask here? What do I tell the user? What do I tell the user in response to this? Can I tell them anything? And then similarly, I think this is more interesting, which is the Kubernetes case. So I can ask them to go off and fetch, I want to go ahead and deploy this particular container. So please go off and fetch my image and go ahead and deploy it. And I could create the code for us to deploy it. And then I could even say step 4 and step 5, please open up a repository and then open up a pull request for that repo. So just giving you a sense. So it goes off and fetched all of the containers and said, okay, which one matches what she was asking for? Okay, that one. So it finds all of the images and then generates some code for me. All right. Back to our regular scheduled programming. All right, so the area of evaluating our agentic app. So I mentioned there are 700 plus PRs in there, and that's just one repo. So ideally, we're not only testing against our own repo. So how do we even figure out what we're good and bad at doing? So we took this repo. We are currently just categorizing all of the pull requests, so setting up the ability for us to categorize each pull request into each one of the big, buckets, problem areas that we're worried about. We go ahead and we run our agent, at each of the versions to see which of the categories are we getting back good and bad responses on. And we evaluate good and bad we can use an LLM, or we can, even better, we're evaluating them with humans. So that gives us an idea. And then we change the system and we test again. So modify the inputs, maybe change the prompts a bit, add some more agents. So that's where we're at this moment. All right. I want to briefly, so we know we want to add some more agents here, and we also want to insert user instructions. So we're expecting to get to something that looks a little bit more like this. But let's go through, what did we learn? It's taken us a long time to get to this point. From the time when I submitted this abstract to the time when we're speaking now, I was really hoping that we'd have a point where we really knew we were getting back high quality results at this moment, and we're still learning about this. So along the way, we did end up launching this agency thing, so we'll, hopefully that gives us some credit for doing something else instead. So we want tools, we need tools to help construct the right agent team. So ways to measure, what are the performance of our agents, what is the performance of our application, how do we do that quite easily? We learned along the way that we needed to make it easier to add or substitute agents. So I highly recommend using a router agent or a supervisor agent and taking that hierarchy approach, because it makes it really easy to extend your system going forward. we really discovered that making highly specialized tune agents takes a lot of time and effort. And if we were able to just pick up some agents off the shelf where someone else had already taken that time to do the specialization and tuning, that would give us a huge amount of benefit, especially if they'd already created like a consortium or a small group of agents that they knew could achieve a task really well. Like we could have a code review agent team that was really good at reviewing Terraform code and publish that and share it to other people. So net out, we really would like to be able to reuse agents. And this is how we ended up here. So right now, agents are very tightly tied to a runtime and a siloed ecosystem. And so we see there's a possible future where we could have a fully open, interoperable internet for agent-to-agent type communication and collaboration. And the tools that we need for this are we need a way to be able to publish agents, discover these agents, see what those agents are capable of, determine whether or not we can even trust those agents. We need a way to take those agents off the shelf and then compose them into our Agentic application. And then we need a way to be able to deploy those really easily as a package, so like a service. So this is our internet of agents. All right, so our call to action. Agency has recently been launched. Please join us. Really, we're looking for folks to contribute to the specifications and the architecture. If you think this is terrible, contribute that as well. Read the documentation, let us know. Use or contribute to the agency components. Join us in this. And share agents. So we've already started publishing our agents, so you'll be able to see the code reviewer agent and the linter agent that we've got already, and review the prompts and just have a look. And then also, if you want to collaborate at all on infrastructure as code agents or pull request reviews, go ahead and talk to me. Thank you.